All right, the new concept for today then is talking about rational exponents. And what I have here is a quick investigation for you, so you can see the pattern for yourself. So remember, rational exponents, this is the same as saying fractions. Fractions in the exponent. Rational exponents are the same as fractions. All right, so usually what I do, just set it up quick, look like this, and I pick an easy fraction. So 4 to the exponent 1/2, 9 to the exponent 1/2, 16 to the exponent 1/2. And usually what I do is I have the class come up and use their calculator to verify or check to see what the result is. And I'm going to do the 3 calculations here. So if we go ahead and do that, 4 to the exponent bracket, and with the calculator I'll go 1 divided by 2. That's equal to 2. 9 to the exponent 1 divided by 2 is a 3, and 16 to the exponent 1/2 is 4. So I'm going to do a quick screenshot here. Let's copy the clipboard. Let's paste it. Here we go. So we have our investigation results right here. Okay, so that's our investigation. So when you go through and you look at this, then we know 4 to the 1/2 according to the calculator is 2, 9 to the 1/2 is 3, 16 to the 1/2 is 4. Hopefully when you're looking at this, some people are saying, I know how to get those results. I also know, and I'll say we also know if I took the square root of 4, it would give me a 2. If I took the square root of 9, it would give me a 3. The square root of 16, that's going to equal 4. So our conclusion then, or our summary, is that therefore square root is equal to, square root of a is the same as saying a to the 1/2. Now what we need to do is we need to extend this to big picture, okay? Because we've got more than just a half as a fraction. We could have many, many, many different types of fractions. So we have to take it one step further. So going another step. Here's something I talked about way back in grade 9, and no, I don't expect you to remember this. However, I mentioned that the square root, when we're talking about this is actually our radical sign. Radical. Okay, this is the radicand. And no, I don't expect you to remember that. And that's not even the important part. The important part is this. Does anyone remember what that was called? And of course, all the hands are shooting up at home. This is what we call the indice. The indice. And when we're talking about a square root, the indice for a square root was 2. But we just never wrote it in. So what happens when we have the square root of a, and again, you would never put the 2 in there, cube root of a, fourth root of a. So again, square root of a, we're looking for 2 numbers that multiply to give us a. Okay, well, we just talked about it above. That's the same as 1/2. The cube root of a is the same as saying I would like to find a number multiplied by itself 3 times. So 1, 2, 3, that would give me a, and it would be a to the exponent 1/3. So the next one, the fourth root, would be 1/4. So the indice, your indice ends up as the denominator. Indice, and here's your indice. Now, if we're looking at the fourth root of a cubed, what we're looking at, and I'm just showing the final step here, inside the brackets is a cubed, and that's the radicand. So what's happening to that term? It has an indice of 4, so it would be 1/4, and using your exponent laws, power powers, you multiply them together, and you end up with 3/4. So we see our indice is still the denominator, And the exponent that we had originally is now the numerator. So our final summary then, and you need to be able to, you want this on your cheat sheet probably, but after you do a bunch of them, you will remember this. So if I have some expression with the radical sign, I can transfer it to become the exponent m is in the numerator, the indice is in the denominator. So that is your rational exponents taken care of. All right. So, write in radical form. So what's basically happening, I'm just going to give us a couple of exponents. So for example, 2 to the 5 halves. And let's go 7 to the 10 elevenths. Okay, so the first one, we want to write it as radical form, which means that we want the radical symbol. The denominator, okay, that denominator is our indice. It's what sits out front. So I will put the 2 in, even though it's not necessary when we're talking about a square root. And inside the brackets, we'll have 2 to the 5th. Similarly, with 7 to the exponent 10 elevenths, here's our radical sign. The denominator, which is 11, we're looking for the 11th root of 7 to the 10. So 11, a number multiplied by itself 11 times gives you 7 to the 10th. All right. Writing it as exponent, basically going the other direction. So if I ask for the 5th root of 2 to the 9th, I want you to write that in exponential form. You write it as 2. The indice is your denominator. So there's the 5. And the exponent that was in there with the radicand, or the 2, goes into the numerator. 9/5. All right. Let's go 100th root of 3 cubed. So again, you have your base, the 3. The 3 would be the numerator. The indice would be the denominator. And there we go. That's all there is to writing back and forth. The reason we write back and forth is this you can do on a calculator, or easy to do on the calculator. Not all calculators have a button that will deal with an nth root. Okay? Not all calcs have this button. Every calculator can handle the exponential form. So that's why it's important to be able to go back and forth. It's also going to be very important later on when we get into logarithms. Still, taking a look to see what we got for time. We're good for a couple of examples. So evaluate the following. So that means we're calculating. Still, a couple of quick examples. If you have your calculator out to work with me, if we want to find the 9th root of 7 squared, again, when I look at the calculator, I got the big graphing calculator here. The BAC, you'll see that when you look at it on the buttons, it has a square root button. Okay, it has a square. Can I write on this? Perfect. It has a square root button, but it doesn't have an nth root. So this is specifically a square root. All right. So it only does square roots. There is no nth root button. Some calculators might have it. It might look like this on your calculator. Okay, but even then, like I said, it's not very common. So, anyhow, going through and calculating this. The only way that I'm going to calculate this one, oops, I don't want this screen here. I'm going to rewrite it as an exponent. So it's really 7 to the exponent 2/9. And that's what I'm going to calculate on my calculator. So with your calculator then, you would plug in 7 to the exponent 2 divided by 9. And we find that it is 1.54. Is close enough. All right, second one. Let's go with the 12th root of 1,000 to the 5th. So again, you need to be able to rewrite it in order to use the calculator. 5/12. And when we check the calculator, it tells us that, move it over a bit, 1,000, oops, that's not 1,000, 1,000 to the exponent 5 divided by 12 equals 17.78. So make sure you can get these answers with your calculator. Very, very important, because there will be some questions that want us to evaluate using those radicals or rational exponents. Now, the hardest part is going to be the simplify part for a lot of people, because you have to use your fractions here. Now, if you have a calculator with a fraction button, A, B, C, if you can find that button on the calculator, it's going to make the examples a lot easier, because we're going to have to multiply fractions. So remember, when you're multiplying fractions, A over B times C over D is equal to AC over BD. Okay? Your calculator, if you can find that fraction button, the calculator will take care of all the stuff that you need to do. So in the next video, in the last video, I'm going to go through a couple of examples, and then you can try the homework with the new stuff.